Now in this lesson, I'm going to talk about how the degree of a polynomial is related to the sum of the multiplicities of the zeros. So let's start with the actual definition that I want to work with here. It says the degree of a polynomial is equal to the sum of the multiplicities of its zeros. So to find the degree of a function, you can take a look at the multiplicities of its zeros. So let's start with this first example here. It says determine the degree of the function f of x is equal to x plus 6 cubed times x plus 2 times x minus 1. So we have three factors, hence we have three zeros. We have a 0 at x is equal to negative 6, another 0 at x is equal to negative 2, and another 0 at x is equal to positive 2. And to find the degree, you take a look at the multiplicity of each of these zeros. And the multiplicity is the power of each of its factors. So take a look at the factors here. X plus 6 has a power of 3. X plus 2 has a power of 1, and x minus 2 has a power of 1 as well. So to find the degree of this function, you can add the multiplicities. So 3 plus 1 plus 1 gives me a degree of 5. So that is my answer. Quite a simple concept. So let's actually look at another example here. It's a little more complicated because we are working with a graph. So it says, what is the minimum degree of the polynomial function modeled by this sketch, given that the function is tangent to the x-axis at these 2 points, 0 and 4. So to find the minimum degree of the polynomial function, what you want to take a look at is the types of behavior that you see at the x-intercepts. And that will give you the multiplicities, hence that will give you the degree. So there's quite a few steps here. The first step is to identify the zeros of the graph. So in other words, the x-intercepts. I have one here, another here, and one at the origin and another one at positive 4. So we have 4 x-intercepts, 4 zeros to work with. Now you're going to look at what happens at each of these zeros, the behavior. Okay, so we start with the first one at negative 9. We know that it's crossing at that point, at that 0, and it's not tangent to, but it's crossing it. So we know that at the multiplicity of that 0 is at least 1. Okay, and same here again with negative 7. It's crossing the x-axis at negative 7. So therefore, the multiplicity of that 0 is at least 1. Okay, now let's move on to the origin. We know that at the origin, it's tangent to that point. So it's tangent to, but take a look, it also crosses at that point. So it's tangent to, it crosses, hence the multiplicity of this 0 is odd. And since we're working with minimum here, the minimum degree here, or sorry, the minimum multiplicity would be a 3. Because it's tangent to and it crosses. Finally, if we take a look at the 0 of 4, it's also tangent to, but also notice that it is not crossing at that point. So since it's tangent to since it's tangent to positive 4, but it's not crossing it, we know that the multiplicity is even, and the minimum multiplicity that's even would be a 2. So since we identified all the multiplicities of the zeros, to find the actual degree of this polynomial sketch, we add up the multiplicities. So 1 plus 3 and plus 2. And that's going to equal to my degree of this polynomial. So 1 plus 1 plus 3 plus 2 gives me a 7. So that means the degree, or the minimum degree of this function, is at least 7. And that's how you use the multiplicities and the degree to, that's how they are related to each other.